Hello. All right, so today we are going to be working on how to sketch a line of best fit from some data. So I've already put up some data here. Now, this is not by definition linear because there's no direct pattern, but I can see that this does trend, it does have a linear trend to it because you can see as you study more hours, your grade will improve. There's just no exact linear term to that. Now, a line of best fit literally means the line that comes to and touches as many points as possible, but doesn't go through every single point. So again, there's some error in this no matter what, and there's not one perfect line of best fit. It's just based on how you draw your graph and if you're doing it to the best of your ability. But if you're doing the line of best fit correctly, we're all going to relatively have a similar type equation. But I'm going to show you a way to go through and do it. So what I like to do is I like to get a straight edge, and after I plot my data, I'm going to see which line would be a best fit. So I can go through these 2 points right here and draw a line of best fit, but my line, if I were to draw this, would go like this, and that would not be close to a lot of my points. So I'm going to go right through my data, and I'm going to do this. So I'm seeing, I always like to try to touch a point or two, and you'll see why. So this one seems like this might be a better line of best fit. Let me see if I can do this. Here we go. So there is my line of best fit. So my line of best fit, according to me, I think this is fine. It's fair enough. It went through. This point doesn't count because it's a little above this point, but I can see it goes directly through this point, and this point. Now here's what I would suggest you to do, because we're going to practice the heck out of this week. This point right here, my marker stopped working. Perfect. Hold on a second. Let's go, there you go. All right. So this point right here is 1, 70. This point right here looks like 2, 77, and this point right here is going to be 5, 92. Got it from my data right here. Now we only need 2 points to find the equation of this line. Now remember, your equation is y equals mx plus b. M is your slope, and this is your y-intercept. Now, I'm not going to use the existing y-intercept because the line that I drew did not go directly through it. So here's what I'm going to do. I'm going to choose any 2 points. It doesn't matter which 2 I choose, but I'm going to choose these ones just because it's smaller numbers and whatever. It's easier. So my equation to find slope, you literally do y2 minus y1 over x2 minus x1, okay? And this will give you your slope. And another way of seeing this is your change in y over your change in x. This delta symbol means change in, okay? So how do you do this? Rather simple. You go in and you just identify which one of these do you want to be your x1, y1. I'm going to make this one my x1, my y1, my x2, my y2. I'm going to identify it because if I don't, I might forget and then switch up the order later on accident. So just always do this. I'm choosing these 2 points. So here's how I do it. Now to find my slope, I'm going to do y2, which I identified as 77, minus 70. There's my change in my rise over my change in my run. And that's 2 minus 1, so my slope is going to be 7 over 1, or just 7. There's my slope, okay? Now, I did all that work to calculate the slope of this line that I made as my best fit, and my slope happens to be 7. So now, I'm going to do this. Find the slope to be 7 according to this line. So as of right now, if I were to replace this equation, I now know my m, which is 7x plus b. Now, I got to calculate what my b is according to this slope and these 2 points. So I can choose either these 2 points to replace with my x and my y, or these 2 points to replace my x and y. It doesn't matter. Just choose a point, replace it to solve for b. Let's replace this one right here. So if I got y is equal to 70, so I'm using the x1, x2, y2 just to show you it doesn't make a difference. 77 equals 7 times 2 plus b. 77 equals 14 plus b, and now we're just solving for b, minus 14. So b equals 63. Look at that. Happened to be that point, and I calculated it correctly, and I got my b. So my equation is y equals 7x plus 63. Look at that. Okay? There's the equation. Now, in today's work, it's going to ask you to find the residual. And what that means is what the actual is minus the predicted. Okay? So I'm going to go through that right now with you. Let's see how accurate this actually is. This is our data. This is our estimated line according to our line of best fit. So here's what you do. Let's take this one, 490. Okay? We already know that this is the actual. Now let's use this equation to find the predicted. So I'll replace 90 with y equals 7 times 4 plus 63. 90 equals 28 plus 63. So let's see, what is 28 plus 63 is 91, 90. So our residual is 1 because residual equals actual minus predicted. So our residual is 1. All right, let's do a couple more examples. This was the data, line and best fit. Let's do 2 more examples of how to find the equation of a line using just 2 points, okay? Pause, maybe rewind and go back, see me in class, ask me questions. Okay, here we go.